Hello and welcome to the Daily Space for today, September 23rd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today, September 23rd, is the equinox. It's that special day of the year when the sun exactly hits the earth over the equator, or at least it does for a single moment in time. And that moment in time was last night at, and here I have to check my notes, it was last night at 1:50 a.m. Eastern Time. At 1:50 a.m., the sun was precisely over the equator wherever in the world. It happened to be exactly, noon at that moment in time. Now, the cool thing about the equinox is it's the one of 2 days out of the year, because we have both a spring and a vernal equinox, when sunlight hits both the North and the South Pole. As of today, the North Pole is going to stop getting sunlight for the next 6 months. And every day, that circle of our world that doesn't get sunlight is going to get a little bit bigger and a little bit bigger. And let's take a look at what exactly is happening. In this video, you're seeing the Earth with the location of the planet fixed relative to the spacecraft, with images being taken at the exact same time every single day. And the reason that you see the shadow tilting side to side is our planet is tilted. We are aligned so that currently the north rotational pole of our Earth is constantly pointed straight at, more or less, the North Star, Polaris. And in the northern summer, the sun is exactly between us and Polaris on the summer solstice. When it's fall or spring equinox, we are directly to the side of the sun on one side or the other, still directly pointed at Polaris. And in northern winter, that sun is behind us as we keep pointing at Polaris. And it's because of that tilt that sometimes the sun is coming in at a really low angle and we just don't get as much sunlight per square foot on the planet Earth, and we just don't get as warm as we would if we were getting more straight down from the sky sunlight. Now, seasonal variations like what we experience are pretty common throughout our solar system. Mars has seasons not too different from our own. But the degree of the seasons does vary as the tilt varies. Worlds like Jupiter that are only tilted a handful of degrees, Jupiter's tilted just over 3 degrees, don't really have noticeable seasons, while worlds like Uranus, which is tipped over 98 degrees. This means that it takes its north pole as defined by the right-hand rule and tips it over halfway and then goes a little bit further. Well, worlds like Uranus that are tilted so that their pole pretty much faces the sun, those worlds have amazingly dramatic seasons. So, all else aside, when someone asks you the reason for the season, let them know that at least as far as summer, winter, spring, and fall have to go, the reason for the season is axial tilt. I know, it's a bad joke. We shall move on from one bad joke to one really deadly world and what may be one of the worst graphics I've seen in a press release. The image that you're looking at is a radar-based image of Venus. That's the orangey stuff. And someone has digitally scribbled over this haphazardly with a blue ocean texture and added clouds and shadow. Now, all joking about this graphic aside, our next press release, which appears to be the last press release that came out of the European Planetary Sciences Conference last week, our last press release looks at the potential of Venus to have been habitable until just 700 to 800 million years ago. Now, from a variety of different radar data, we have hints that, well, Venus may have once had massive oceans. And running a series of 5 different simulations that each started with a different amount of water on Venus 4.2 billion years ago, scientists led by Michael Way have tried to figure out what the climate history of Venus could have been. And in all 5 models, they find that Venus had a stable climate that had temperatures that maxed out at 50 degrees Celsius. And those temperatures may have lasted for billions of years. Now, 50 degrees Celsius is just 120 degrees Fahrenheit. And that's pretty much considered a nice day in Phoenix in the summer. These are temperatures we're familiar with. And the unfortunate part is that here on Earth, 700, 800 million years ago is when life was first starting to emerge, when the first flagella-waving protists were starting to, well, be found in the fossil record. So if Venus developed life at the same rate as Earth, that life may never have had a chance to emerge. But if for some reason things ran just a little bit faster in that little bit warmer, or rather a lot warmer climate, it's possible that the first mass extinction that our world ever saw, not our world, our solar system ever saw, was a mass extinction on Venus. Now, it's unclear exactly what happened that ended this situation, but something happened that triggered the massive release of carbon dioxide and monoxide that had built up in the internal, well, soils, ices, rocks on Venus. And this catastrophic outgassing event that occurred 700 to 700 million years ago brought Venus's life-carrying capacity to a sudden crash. According to project scientist Michael Way, something happened on Venus where a huge amount of gas was released into the atmosphere and couldn't be reabsorbed by the rocks. On Earth, we have some examples of large-scale outgassing. For instance, the creation of the Siberian traps 500 million years ago, which is linked to a mass extinction, but nothing on this scale. It completely transformed Venus. So we don't know for sure what caused all of this outgassing to occur, but what we do know from radar measurements is that Venus had massive volcanic systems across its surface. And there are some papers that postulate that a buildup of heat internal to Venus was let loose through a planet-wide, basically uplifting and volcanic eruption. And it's possible that this kind of an event is what triggered the amazing greenhouse effect that we now see on Venus that raises its temperatures to the highest temperatures seen in our solar system, not associated with the surface of the sun. So yeah, from one dead world to another, we now hop over to something that was supposed to be dead. And this is Ryugu. It's a small asteroid in an orbit that crosses the orbit of our own Earth. This near-Earth object is currently being orbited by the Hayabusa 2 spacecraft. And that spacecraft last week dropped, and here you can see images of one of those drops, 2 little target markers onto the surface. Now, this particular image looks like what we're seeing is a multiple exposure of that target marker dropping down towards the surface of Ryugu. What we're actually seeing is the spacecraft lifting up. The gravity is so low on this little asteroid that it's actually going to take those surface markers a couple of days to sink down. And that process from the release last week got monitored and continues to be monitored through today. This is part of the last step in preparing the mission to deploy Minerva 2, the last of its 3 rovers. We don't yet have an exact date for when that release is going to occur, but it won't be too long now, because after that Minerva 2 is released and does its science, hopping around the way its predecessors did, Hayabusa 2 is going to fire its ion engine in November and head on back to Earth. Now, this isn't going to be a fast journey. Ion drives don't provide all that much acceleration. They just get the job done. It's going to be next December 2020, when Hayabusa 2 flings its sample of surface soil from Ryugu back at Earth to be caught somewhere over the continent of Australia. And I just want to point out, I find it absolutely amazing that we can be this accurate with our spacecraft, that they can put this little spacecraft into an orbit that will allow it to release basically a bundle of rocks at just the right velocity and at just the right time, that they can tell from millions of miles that those rocks are going to hit Australia. And I know Australia is a big continent, but just enjoy this good news with me. This is pretty amazing engineering. Okay, that's all the news we've got. Last week, we had more than enough news for several weeks, and we brought it to you all as it happened. And now we get to enjoy things a little bit more this week. So this week, I will be hosting this show on my own, which means you get to hear me try and bring you a rocket update on Wednesday, and rockets are not my area of expertise. Annie is taking a much-deserved week to take care of a variety of other things that needed to be taken care of. And next week, she'll be doing double duty as I fly out to Tucson, Arizona, where I'll be visiting our headquarters of the Planetary Science Institute. And so you'll see different backdrops next week. So this has been the Daily Space. We come to you most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. We are brought to you by you. We are able to pay our staff, pay Annie, pay Susie, who does all of our production, a living wage for what they do. And we can only do that thanks to your donations of bits, of subs, of, patronage over on patreon.com/CosmoQuestX. Thank you for all you do. And thank you for I think that's a follow. I can't quite see that far. I hope I have the correct window open somewhere here. Continuing the wall of text. Thank you for everything you do. There's another one of those happy noises. I still can't see what's causing them. And I'm going to have to ask you to re-enter all of your questions because I forgot to open this window before we started. Oh, man. Mondays, people. Mondays. So, if you can't support us financially, we totally get it. I can't support everything I want to financially. But the thing you can do is get the word out. Tell people who are interested in science, hey, there's this great thing you can listen to. You never know whose life you're going to change by introducing them to science. Okay, so I hate to say this, but I need you to type your questions in because I literally had a bumpy start to the beginning of this show. I'm going to pause for a moment and I'm going to, let's see if I can figure out how to do this from here. What I want to do is bring you, wow, I can't see that far. Okay, I'm just going to figure out how to cancel that. No, I'm not. I'm apparently just going to completely botch up okay, we're stuck on this screen now. The room that I'm in my little studio area right here, but the computer that is controlling this stream is on the other side of the room. And I stood up from the desk over there to walk over here and promptly tripped over all of the cables. and unplugged the sky cam, and yeah. So I did some last minute fixing of all the cables and plugging everything back into the USB hub just as we are starting. And the result of that is I forgot to open chat. I am so sorry. Okay, I'm now going to look at chat. Susie says, from Veronica Cure, could Yellowstone volcano cause Venus terraforming of Earth? I don't think so. I don't think it's quite big enough. It definitely would cause a mass extinction event, however. With that kind of a volcanic eruption, I believe the primary issue that you'd run into is long-term cooling problems by having that much debris thrown up into the outer atmosphere. So you have three things you have to worry about. One is the amount of stuff that goes up and then must come down, and all of its kinetic energy gets turned into heat energy in the atmosphere as it hits terminal velocity. So you heat the atmosphere up with that. This is what killed the dinosaurs, was all the debris that got splashed up and came back down and baked the atmosphere. The next thing you have to worry about is how much carbon dioxide and monoxide and other greenhouse gases are released into the atmosphere. That causes warming. The third thing you have to worry about is how much dust and debris gets suspended in the atmosphere, leading to long-term cooling. So what we're probably looking at with something like Yellowstone going off is an unknown amount of initial heating occurred, followed by long-term cooling due to all of the debris left suspended in the atmosphere. Figuring out the physics of this is tricky, and I'm really glad I'm not an astrophysics scientist. Okay, I hope that depressing answer sated your curiosity, which was good curiosity, just in a depressing direction. Hello, Arts of Space. Trying to keep up the good work. And your art is fabulous. Feel free to drop in a link and shamelessly promote yourself. We like to support the arts around here. So Larry asks, if the Earth has no tilt, would weather be worse or better? I realize no seasons. So if the Earth was not tilted, we would have a different set of convective cells built up on the planet. And we'd probably have significantly more dramatic hurricanes. But they wouldn't be driven the same way, I don't think. Hold on, thinking. I was giving answers before thinking. I want to say that we'd end up with a larger number of convective bands than we currently have. And these are what control things like the trade winds, which run counter to the direction of currents and allow you to sail from California to Hawaii. I suspect the bands that these different winds are in would be narrower, allowing us to have more bands. But again, not an atmospheric scientist. So basically, I think the weather would be more fiddly, but probably also more repeatable and more constant, since you don't have the seasonal variations. So we wouldn't have the massive upheavals that are related with fall and spring. It's these upheavals, for instance, that cause hurricane season to occur in part. Yeah, sorry, I don't know better. Bad Panda is asking, would Venus have had plate tectonics when it had oceans? It's currently believed that Venus didn't have plate tectonics, and that's what caused it to eventually have a massive volcanic upheaval that just destroyed the planet. There are no this is what happened, because we haven't been able to land rovers long enough to get significant data. They tend to melt. Venus is hot and gross and eats landers. It eats them hard. So we need more data, but current thinking is Venus did not have plate tectonics. So Susie says, from our instro, is will anyone be doing the HTV launch tomorrow? Yes, but I'm going to need prepped. Arinstro, you're going to become my new best friend at some point today. You already are a good friend, but you're going to become today's best friend. Okay, yeah, Astro-wise, Monday. Mike Cassidy, bruising? I don't know what you're referring to. I'm sorry. Oh, to my tumble? No, I don't think I bruised anything tumbling over all of my cables. I just felt stupid. There's nothing quite like landing in a heap of, it appears to be one power cable and 5 USB cables, 6 USB cables, 5 USB cables. I can count, really I can. Yeah, me and all the cables. All the cables. So also from Larry, a zero tilt Earth would have worse or better weather. Different. I'm going to go with different. DPI 209 points out, dinosaurs might have had a problem with a certain 100-meter tsunami around the world as well. I'm going to repeat it one more time because I cannot repeat this enough times. My favorite caption ever, and I'm going to paraphrase it here, is from Scientific American, and I need to find it and retweet it. I tweet it about once a year. My favorite caption ever is from a Scientific American article that pointed out that the shock wave of the asteroid impact was so great that it flung soil, plants, trees, and dinosaurs at escape velocities up into the atmosphere. This means that the first life forms to enter outer space were very dead dinosaurs. I just find that awesome. How does one scale a tsunami anyways? Yeah, at a certain point, tsunamis are just deadly or planet destroying. So you have small and respectable. These are the 1 meter ones that sometimes hit Hawaii and other places that can be deadly, but if you pay attention, you should be fine and be able to get high enough up to be safe. And high enough up isn't very far from shore. Then there's the 10-meter ones, and those are extremely destructive. And then 100 meters is, let's just destroy the planet. So it kind of goes from eats a few people, but if you have warning, you can get away, to makes entire shorelines really sad, to no more Earth. Well, Earth is still here, but you know what I mean. Anyways, continuing on, scrolling through the chat. I love your use of emotes, Arinstro. Yeah, Susie's right. Arinstro did totally get voluntold. Larry points out spaghettification of atoms would lead to quantum gravity. I don't know. I personally am of the school of thought that gravity is just not going to let itself become part of the standard model through quantum mechanics. If Einstein's idea that gravity is simply the shape of space, the stretching that occurs in additional dimensions to basically cause gravitation to be essentially downward, and if that geometry-based explanation is real, then you don't need the quantum mechanics. It's still a mess. So, yeah. Again, not a theorist. So Hanny asks, would a water world have a similar weather to a surface world of the same size? No, because the thermodynamics are very different. Water has a completely different way of transmitting and holding on to heat than rock does. This is why the desert gets so cold at night. If you have a dry, rocky world, it can radiate away all of its heat on the night side, whereas a wet world will just hold on to all of that heat going, yeah, and this is why desert heat and humid tropical heat may have the same temperature on a thermometer, but they feel vastly different. Water just has different thermodynamic properties. Scrolling for more questions. The scariest of math, quantum gravity would be. I don't know. I still kind of give it to magnetohydrodynamics. I still consider that gnarly because that's a three-dimensional problem. Okay, so that brings us to all the questions answered. So to give you a roundup of what's going on, I am here all this week. I am canceling plans to go to TwitchCon because it was the right thing to do. I'm working on finishing up a grant proposal, and we should be having a grant going in October 1 with more grants following in November. Now, this doesn't mean that we're going to stop asking you for funds, because the grants that are going in to fund research. We are looking for sponsors to support our media programs, such as the Daily Space. If you know anyone, we could use a sponsor or two. Bamba socks would be great, but so we are working on grants. We are also working on planning the Hangout-a-thon for December, yet again this year. And beyond that, next week on Tuesday, I will be flying out to Tucson, Arizona, next Saturday, which is International Observe the Moon Night. I will be giving a public talk at the Flandau Center. You can find it announced on their website. Any of you who are in the Tucson, Phoenix area, please consider coming down to Tucson to see the talk, hang out with me, and let's just observe the moon that we all share. Beyond that, looking forward, I will be attending QCon in San Francisco in November. I am looking to put together a meetup related to that. It will probably be at a pub somewhere. I'll see what I can identify. January. Okay, so December. I knew there was a month in there. So October, you can see me at the International Observe the Moon Night at the Flandau Center in Tucson, Arizona. November, you can see me in San Francisco associated with QCon. December, Susie, Annie, and I are going on what may be described as a pilgrim to Kennedy Space Flight Center I think it's the second week, first full week of December, so that we can hopefully see a launch of a Falcon 9 on a resupply mission to the International Space Station. This means we will be bringing you launch coverage from a launch, which is kind of exciting. In January, I will be attending the American Astronomical Society meeting in Honolulu, Hawaii. And I'm hoping in February to go out to San Diego to visit our good friends at Oceanside Photo and Telescope. That is pending a grant that we are waiting to hear on that should be in the process of getting transferred. So those are the things coming up in the near and far future. Now, some of you have been asking about Bennu and that tattoo that I hinted at getting. Well, I'm not getting it before TwitchCon because life. And you guys didn't finish on time. So that will still be happening. I just don't know when. Stay tuned. So yeah, that's all I've got. That's all I know. We will be publishing all of these dates when I get a chance to catch up on everything. Thank you. Thank you for everything that you do. And Open Cage is asking a question I'm missing the content, the context on. Yes, DPI 209, we do need a 30-hour day. Mars at least gets you an extra 45 minutes, but it's a little hard to get there. The Yucatan impact. Yes, Mars would have been bone dry by then. Okay, so I think that's everything. You guys are awesome. Let me see if I have anyone to thank. Thank you, Trucker Kev, for resubscribing for 8 months. That is amazing. You are almost a Twitch baby. For those of you who don't know what that is, it's a really creepy way of saying that people who have subbed to you for 9 months are a child of your show. And it's also wrong because it turns out, and they don't teach you this in high school, that babies actually take 10 months. It's 40 weeks. I'm so glad I don't have children. If I learned that when I became pregnant, I would have been so ticked off at everybody. Anyways, thank you, Trekker Kev. That's awesome. I'm so glad to see you re-upping to be a subscriber one more time. Get all those emotes out, people. Get all those emotes out. I think that puts us within like 3 subs of hitting our monthly goal. I'm trying to find a window that might tell me. Dear Windows, there are too many of you open right now. We're within 2 subs of hitting our monthly goal. Thank you, Trucker Kev. 2 more, he says, with 2 bits. That is excellent. And Mythtown is gifting 1 tier 1 sub to the community. Thank you, my Lerna. Get out and use those emotes. Use those emotes. Thank you, Mythtown. Thank you. DPI 290 is saying 40 weeks equals 280 days equals 9 months. Okay, I can't calendar math. Nonetheless, I can't calendar math. And Guido's pointing out that his resub is coming up in a couple of days. And Mythtown, you guys are going to let us surpass our goal. You're awesome. You're absolutely awesome. Thank you so much, everyone. This is amazing. Woohoo! Planetary Pan also gifted a sub to Arts of Space. Arts of Space, I really hope you enjoy all of our spacey emotes and use them fully. All of you, use your emotes fully. Show your spacey pride everywhere you go. Let's get roving and orbiting and enjoying emotes. It's what we've got. You guys are awesome. Thank you. Okay. I'm running out of things to say. Number 1, Hanny's war verb types. So I'm going to go make a podcast out of this. And this is your reminder. We have a podcast. Please go subscribe. Now, you don't have to listen to podcasts, although I'd really like it if you listen to podcasts. But just subscribing really makes it easier for other people to find our episodes. It turns out that when your show is named The Daily Space, those 3 words exist in a whole lot of podcasts, and all the podcasts that have those 3 words all come up in the search results. So please help other people find us and go out and give us a subscription. dailyspace.org. Just click on the little podcast icon. Also, I think that, the RSS feed is in the chat. Also, go give a subscription to our YouTube channel too, if you can. These are all ways that you can really help us out that cost you nothing and mean a lot for us. So if you do nothing else to help us out, can you subscribe to our podcast and our YouTube channel, and help us get found by more people. Like I said, you never know whose life you're going to change by giving them science. Okay, we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring this solar system and beyond. We're brought to you by you, but production has to be done by someone, and that someone is Susie Murph. This channel is hosted by myself and Annie Wilson, with help from Paranor, who does co-streaming for us of many different events. We don't just bring you the Daily Space. We also bring you Sunday Science Hour, hosted by Annie on Sundays, which is redundant, but true. We co-stream the weekly Space Hangout and Astronomy Cast, thanks to the help from Paranor. And then we bring you launches, landings, and all the special events in between. So check it all out. And we will be here to put science in your brain. Have a fabulous morning, evening, afternoon, and I'll see you on the other side. Bye-bye.